Please use these chroma depth glasses on the color slides. And if you don't have one, please raise your hand. Okay. Here's a map of Mars. It's made from NASA topographic data and has been colored to show the highs and the lows and the elevations. So the blues and the greens are the lower elevations, and the reds, oranges, and yellows are the higher elevations. We worked with NASA topographic data to look at the landforms and the possible role of water in forming them. Water is important to life as we know it on Earth, so that's why scientists are studying places on Mars that may have been wet sometime in the past and where life may have existed long ago.
Hit from current slide.
Okay. Our team's focus was an impact crater named Gale Crater. As you can see, it is located on the border between the lowlands in the north and the highlands in the south. Gale Crater is the landing site to Curiosity, which is the robotic rover of NASA's Mars Science Laboratory mission. Part of Curiosity's assignment is to study the geology and search for evidence of water in the rocks and soil. And if any of you are wondering how big Gale Crater is, this is a comparison of Gale Crater, which is the dark circle in the middle, to Hokkaido, Japan, the outline. So it's about 200 kilometers across. And using your glasses, please examine this other false-colored topographic map of Gale Crater. Notice Mount Sharp, which is the yellow spot in the middle. Its summit is yellow because of the really high elevation. The rover, Curiosity, landed on the northern floor of the crater in the darkest blue area up there and is traveling towards Mount Sharp.
We use the ENVI software, the program which scientists use, to create these different ways of visualizing image data. It was easy to learn the software thanks to our mentors, Linda Martell and Jeff Taylor. And as you can see, the slide gives us a perspective view of Gale Crater. And notice Mount Sharp in the middle. Right there. The southern rim is higher than the summit of Mount Sharp, and you can tell that through the different reds. As the red is darker on the south than the red on the summit of Mount Sharp. Also, please notice the varied elevations that Curiosity has to traverse. So, using ENVI, we were able to create this wireframe way of looking at the crater. And this program allows us to extract image data taken from NASA and allows us to create 3D visual images such as this. So this is another topographical profile. It's of the red line at the top right corner. And the red line traverses Gale Crater, as you can see, from west to east. And Gale Crater was formed by meteoritic impact long ago. And from west to east, as previously stated, is about 200 kilometers across. You can tell from the graph where the crater rim and the other crater rim are, and you can see as the line goes along the crater itself, you can see the different elevations, up and down.
So this is a selfie that Curiosity took. So it had a camera up on its arm and it rotated around and took multiple images. So it's basically a mosaic, which is why you cannot see the arm in the photo. And some background on the Curiosity rover. It was launched November 26, 2011 and landed at Gale Crater August 6, 2012. And it was sent on a mission to gather data from Gale Crater to determine its past habitability and search for water, or evidence of water at the, And it is, okay. This is okay, you need to go to the next slide. This is a video from one of its many cameras. As you'll, it's not playing.
Slide.
What
Go to
else?
from current slide.
If the video were playing, you would see it would collect soil from the ground with a tool called a soil scoop. And what that soil scoop will do later is put it into an instrument called SAM, which stands for Sample Analysis at Mars. And it's important for analyzing chemical building blocks such as phosphorus, carbon, hydrogen, and other elements in the rock or soil samples. So within 2 years, the Curiosity rover has traveled 9.5 kilometers, and it's from the blue star over there. And it is currently moving along Pahrump Hills, the dark region you see on the screen. And if you're wondering why Curiosity is moving so slow, it's because its top speed is 0.14 kilometers per hour, and it takes scientists and engineers across the USA about 8 hours to plan one of Curiosity's days. One of Curiosity's days consists of things like moving around rocks and collecting those samples, and then putting it on SAM and making sure it doesn't blow off because the high velocity Martian winds. And also moving around is very difficult without getting caught in sand dunes. Even if the day is dedicated to just drilling a single hole, it is very valuable. And we learned this from Scott Rowland, one of the volcanologists on the Mars projects. He spends most of his days planning Curiosity's movements. He was very nice to meet and interesting to talk to. As you can see on the screen over there, Curiosity took a little detour to a place called Yellowknife Bay, which my sister will talk about more.
Okay, so here's a picture that shows the landing site in Gale Crater, Yellowknife Bay, and Mount Sharp. And so the black areas that you see are actually sand dunes, and the lighter spots in between the sand dunes is where the rover plans to go. And Liana mentioned earlier about the detour to Yellowknife Bay, so I'll explain that in a second. Okay, so here are pictures taken by the rover from Yellowknife Bay. These are mudstones. And Yellowknife Bay was an interesting stop because it contained a variety of minerals in its soil and dirt. And they contained important clues for possible life on Mars. After examining the dirt, geologists found that Yellowknife Bay was once a large body of water like a lake, so that would explain the clay mudstones and the lower elevations in Yellowknife Bay. Scientists also discovered that the pH level was neutral, so it wasn't too basic or acidic, and the element schnapps, which is carbon, hydrogen, nitrogen, oxygen, phosphate, and sulfur, were also discovered, and those, as you might know, are ingredients for living organisms. And all of these facts make Yellowknife Bay a favorable location for possible life on Mars, although there was no real evidence that proved life previously existed on Mars. So moving on from Yellowknife Bay is the rover's carefully planned route around the sand dunes, which are the black areas again. And if you think about how long the rover has been traveling and how far it's gotten, this plan will probably take some time as well. Here's a picture taken by Curiosity of the rock layers at the base of Mount Sharp. These layers are what brought scientists to Gale Crater in the first place because they may have minerals that have been altered by water. And these rocks contain clays and sulfates. Our mentors, Jeff Taylor and Linda Martell, showed us earth rocks similar to the rocks Curiosity is finding on Mars. We looked at mudstones and shale. Then we actually got the opportunity to look at a real Mars rock. Luckily, the University of Hawaii has real Martian meteorites. And since no rocks have ever been collected and returned to Earth, the only ones that we could obtain were ones that fell from meteorites. In this picture, our mentor Linda is holding a Martian meteorite named Zagami. It is named after the place where it was found in Nigeria. And here's a picture of our entire team. We would like to thank our mentors Linda Martell, Jeff Taylor, Art and Reed Kimura, Antarige, and Scott Rowland. Thank you very much. Mahalo!
Thank you very much for your wonderful presentation. Do you have any question? I think we have no more questions. So I'd like to ask the commentators for comments about this presentation.
Well, I'd like to thank you. That was really interesting. The quality of your images is stunning. Even if you had a little technical difficulty at the beginning, it was worth waiting for. Thank you. Your presentation was really very informative and very well put together. Thank you. I was absolutely astonished at the amount of data that seems to be coming back from Curiosity. Can I ask you a couple of questions about it? I'm sure you've probably researched a lot more than you actually talked about in your presentation. I've got to ask this, everybody will ask, has it found water in those soil samples?
Well, because they went to Yellowknife Bay and they found those mudstones, just the fact that it was clay and mud kind of implied that there was water there.
That water had been there, yes, yeah, okay. As far as, sorry.
Oh, so we also found that like underneath the surface of Mars, it's frozen.
Yeah, I think there's ice. Ice underneath, not.
How far underneath, do we know?
I can't remember the exact numbers at the moment.
So what's Curiosity doing? Just scraping the surface? Doesn't dig?
Right now, it's just collecting dirt samples, and because, as Liana said earlier, it takes 8 hours to plan activity. It's a lot of work. So
Very tedious.
yeah, it's very tedious. So we haven't gotten, or the rover hasn't gotten that far.
But it's making progress
Yes,
every
very,
single
very
day.
slowly.
Yes, thank you. Absolutely fascinating. And now I'm sure that a lot of people here will start to look out for information and news about it and follow it and see what it finds next. Thank you.
I would like to congratulate you all because we have been seeing these clips in the news generally, but this was really better than those collections, so I must congratulate you for that. And another thing that I would like to share with you, that you said water was there. Is it an assumption or it is there? There is a difference in that. So what do you say? The scientists are saying water is there, water was there, or they are just assuming that it could be there. So you must have.
One of the other evidence that they found was in the rocks. There's like indentations, like it looks like splash marks. So they're thinking when maybe when the crater, it's impact crater, so maybe when it was hit, like water sprayed out. That's what they're seeing in the rocks. So that's another.
So these are the assumptions, and I'm very sure day by day more data is being collected, and we are very hopeful that we find water over there. All the best and keep on going. Thank you very much.
Thank you.